Welcome to General Physics 1. My name is Arian Entubado from STEM 12 Edison. Our lesson for this video is addition of vectors. It has a graphical method and component method. But let's find out what a vector is. Vector, quantities expressed by magnitude and directions. We can add vectors in two ways, by drawing it through the graphical method, by computation, or the component method. Graphical method. The graphical method of adding vectors A and B involves drawing vectors on a graph and adding them using the head-to-tail method. We will plot vectors so that we could find the resultant vector, and we will use a ruler and protractor. Component method. We only use a calculator. It's a process of adding vectors, and based on the name, we will rely on the x and y components for each vector in finding the resultant vector. The resultant vector is the sum of all individual vectors which still has magnitude and direction. We are going to use mathematics in finding the resultant vector. To find magnitude of the resultant vector, we will only use Pythagorean theorem. R squared is equal to x squared plus y squared. By squaring our x and y components, we also find direction. We will use the trigonometric functions, mainly the tangent functions. We will use as formula tangent theta is equal to opposite over adjacent sides. Now, we will solve two problems. Our problem with the graphical method is mark road the boat and move to 7 meters east, 8 meters 60 degrees north of east, 12 meters south, and 6 meters 20 degrees north of west. What is the resultant vector? Our vectors are 7 meter east, 8 meters 60 degrees north of east, 12 meters south, 6 meter 20 degrees is north of west. We will draw the vectors on the grid so that we can find the resultant vector. But before we start, each grid will represent as 1 meter. 7 meter east, 8 meter 60 degrees north of east, 12 meter south, 6 meter 20 degrees north of west. It started from the east, then went to the south to form our angle. Our resultant vector is 6.15 meters, 29.40 degrees south of east. Our problem with the component method is Kevin pushes a box. He exerts a force to 9 meter east, 8 meters south, 4 meters 30 degrees north of west, and 1 meter 40 degrees north of east. What is the resultant vector? Our vectors are 9 meter east, 8 meter south, 4 meter 30 degrees north of west, and 1 meter 40 degrees north of east. We will use the table of components to find out the x and y components. Our first vector is 9 meter east. Our x component is positive 9 meters and y component is 0 meters. Our second vector is 8 meters south. Our x component is 0 meters and y component is negative 8 meters. In the third and fourth vector, we will use the trigonometric sine and cosine function to find x and y components. We also use tangent function. Before we do that, let's find out the direction of 4 meters 30 degrees north of west. It started from the west, then went to the north, and our angle theta was 30 degrees.
The imaginary line is the opposite side of the y-axis and the adjacent side is on the x-axis. 4 meters 30 degrees north of west. We have y component and x component. Sin theta is equal to opposite over hypotenuse is equal to V3y over V3. Substitute the sin theta is equal to V3y over V3 and cross multiply V3y is equal to V3 sin theta. Our V3 is 4 meters sin 30 is equal, we will use calculator. 4 sin 30 is equal to 2 meters. Next is x component. Cosine theta is equal to adjacent over hypotenuse is equal to V3x over V3. Substitute the cosine theta is equal to V3x over V3. Cross multiply V3x is equal to V3 cosine theta. Our V3 is 4 meters cosine 30 4 cosine 30 is equal to 3.46 meters.
Our third vector is 4 meters 30 degrees north of west. Our x component is negative 3.46 meters and y component is positive 2 meters. For the x and y components of the fourth vector, we will use again the trigonometric sine and cosine function. But before we proceed, let's find out the direction first. 1 meter 40 degrees north of east started from the east, then went to the north, and our angle theta was 40 degrees. The imaginary line is the opposite side of the y-axis, and the adjacent side is on the x-axis. One meter 40 degrees north of east, y component, and x component. Sin theta is equal to opposite over hypotenuse sides is equal to b4y over b4. Substitute the sin theta is equal to b4y over b4. Cross multiply to b4y equal to b4 sin theta is equal to 1 meter sin 40. We will use calculator. 1 meter sin 40 is equal to 0.64 meters. Cosine theta is equal to adjacent over hypotenuse equal to b4x over b4. Substitute the cosine theta is equal to b4x over b4. Cross multiply b4x is equal to b4 cosine theta is equal to 1 meter cosine 40 is equal to 1 cosine 40 is equal to 0.77 meters. Our fourth vector is 1 meter 40 degrees north of east. Our x component is positive 0.77 meters and y component is positive 0.64 meters. Add all x components and the answer is summation of x is equal to 6.31 meters, and also add all y components and the answer is summation of y is equal to negative 5.36 meters. For our magnitude, summation of x is equal to 6.31 meters. Summation of y is equal to negative 5.36 meters. Resultant vector is to square root the summation of x squared plus summation of y squared. Resultant vector is to square root 6.31 meters squared plus negative 5.36 meters squared. Our resultant vector is the resultant vector is equal to 8.28 meters. For the direction east of south, the resultant vector is 8.28 meters, so that our angle theta is 40.35 degrees. It is started from the south, then went to the east, and our angle theta was 40.35 degrees.
The imaginary line is the opposite side of the x-axis and the adjacent side is on the y-axis.
For the direction, tangent theta is equal to opposite over adjacent sides. We derive that theta, so we have theta is equal to tangent inverse opposite over adjacent sides is equal to, so that theta tangent inverse of negative 5.36 meters over 6.31 meters the final answer is 40.35 degrees. Our resultant vector is 8.28 meters, 40.35 degrees east of south.